Good evening everyone. Today we are going to do the daily Leetcode challenge of 15 January 2023. That is question number 2421, number of good paths. It is a hard Leetcode question and it is a very good question. You may find various solutions for it, but I will give you the easiest and optimized solution you can find for it. Okay. So let us understand what the question is saying. The question is saying that there is a tree. It is a connected tree, undirected graph, and it doesn't have cycles. Okay, and it is having n nodes numbered from 0 to n minus 1 as usual, and it is having exactly n minus 1 edges. It is a similar pattern for every graph and tree question. Okay, and the index starts from 0 index, and we are given an array value which denotes the value of indexes, and we are also given a 2D integer array which denotes the edges between them, between the vertices. Okay, and a good path is a simple path that satisfies the following condition. We have to return the number of distinct good paths. And a good path is a simple path that satisfies the following condition. That is, the starting and ending node should have same value, and all the nodes between the starting and ending node should have less than or equal to the starting node value. Okay, and we have to return the number of distinct paths. So for returning the number of distinct good paths, let us consider the example. They are saying that what is a good path? These all separate nodes are a subtree. Okay, so there are minimum n number of good paths available: 1 2 3 4 5. So 5 is the minimum number of paths available because each of them are individually a good path. Okay, that is what the question is saying. And now we have to find other good paths. What is the condition for good path? It is saying that the starting value and ending value should be same, and the values in between the nodes should be less than or equal to. But between 1 and 1, is it the case? No. So it is not a good path. Let us consider for 3. 3 has the same value for 3, and all the values in between are smaller. So it is a good path. So total answer will become n plus 5 plus 1, that is equal to 6. Let's consider the second example. It is saying that the number of good paths. So what I told you, what will be the minimum number of good paths? 1, 2, 3, 4, 5. So 5 would be the minimum number of good paths possible for the tree. Okay, because each of them individually is a good path. Now we have to find other paths between 1 and 1. It is a good path, yes, because they are having equal or less value. Okay, and for 2 and 2 it is also a good path. So total how many good paths are possible? Total 7 is the answer. So sir, we understood the example and we understood the question. How can we approach it? Can you tell me? So first I request you all to please think of trying this question as I have explained you the examples. So please try this on your own and then come back to the video. So now I hope you have tried the question, and to approach this question what you can do. For this question we are going to use a disjoint set union method which I used it in the previous video as well. If you haven't checked out that video, please check out that video, that will help you to understand better. So now what we have to do, what we can do, we can sort the edges according to their weights. So we don't have to check for other paths. Yes, we don't have to check for a path between 1 and 1 which has a bigger value in between these. If it was sorted by edge weights, yes or no? So if we sort it by edge weights, 3 would be at the top, 3 would be at the top, then there would be 2, and then there would be 1. Yes or no? So we will avoid extra traversal. Yes or no? And we can get the answer optimally. So that is what you have to do. So what you do in disjoint just union function, we create a parent array, and parent will store the bigger value. Yes or no? As I told you in the previous video as well, if the parent of this one is which of them should be parent? So what we do in the disjoint set function, if these two are the a and b, which of them is having a bigger value? Suppose it is 5 and it is 15. So bigger value is of 15. So parent of 5 will be 15. That is what we are going to do in the frequency array. Parent of 5 is 15. That is what you have to do. So whenever 5 is called, its parent will be called. So this is how you are going to check for the parent function and check whether there is a good path available or not. Minimum paths we can easily get, but extra paths we will find by using the parent function. If the path is possible, then it will be sorted and we can easily get it. Yes or no? Let's see the code and understand it better. So for starting the code, let me just zoom it for you. So now what we have to do, we will initialize the int n is equal to vals.size to store the minimum number of nodes. After that, we will create a map which will store the maximum element value. Yes or no? What do you mean by maximum element value? Suppose there is 5 and 15, which I told you earlier as well. So between this, which is the maximum element? 15 in a. So we have to store in a map that 15 is the maximum element. So 5 is pointing to 15. We have to make it its parent. That is what I mean. And you also have to store the count. Yes or no? So you have to store the count of the element as well. So you can get the frequency. Why you need the frequency? Suppose there is A and there is B element and both of them are equal, and it is having 2 frequency and it is having 3 frequency. So what would our answer be? Answer would be product of the frequency of 2, that is 2 into 3. Answer is the product of frequency of A into frequency of B. Please think about it and make a dry run about this as well. It is a key concept. As I told you, between 1 and 1 a path is possible, but if it was also 1, another path is possible. Yes or no? Think around it and check whether I am saying right or not. It is a task and assignment for you. Okay, so now what we have to do, let's move on with the code. So now what we will do, we will start a loop for int I is equal to 0, for I less than n, I plus 1, and what we are going to do in this loop, we are going to assign the parent vector. But before that, we should create a vector parent. Yes or no? And it should be of size n. In this parent vector, we are going to assign the values. Initially it will be initialized with the index number, and the max element will be initialized with the values, and we also have to get the count of every element. Yes or no? That would be count I is equal to 1. What I mean is, we are going to initialize the parents and we are going to get the count of every element, and we are also going to get the maximum element. Okay, when you are done with this step, you have to sort the edges. I told you now, we have to sort the edges accordingly, so we don't have to iterate through a wrong good path. We only iterate through a good path if we have sorted it, and it would become easier. Okay, so how can you sort it? You will write sort edges dot begin comma edges dot end. You can sort it like this, but for a better accuracy, we need to sort it by writing a function. You can either write the function above or you can write the sort function here as well. How can you write it? You write it like this, and you write constant vector and a constant vector and b, and you write the return function here, and here you have to get the maximum values. So int m will be equal to maximum value of a 0 comma vals a comma 1, and int n is equal to maximum of vals b0 comma vals b1. And when you get the maximum of the two edges, you are going to return m less than n to sort it in ascending order. What it is doing is, it is comparing the edges. 1 and 0 are getting compared, 5 and 15 are getting compared, and suppose 3 and 6 are getting compared, and the maximum of this is 6 and the maximum of this is 15. So 15 will be placed above 6. Yes or no? So it is getting sorted in ascending order. 6, then 15. That is what we are doing. We are sorting it. So when this is sorted, the sort function is over. So now what we have to do, we have to get the answer. So initially answer would be equal to n, the maximum number of values available. Yes or no? As I told you in the explanation. And there can be more good paths, and that we have to find. Now we have sorted the edges, we can easily find it. We will iterate through it. How we can iterate? For auto v2 edges, what we can do, we will get the a. What is a? It will now we have to apply the union function. How you are applying the union function? We are applying the union function in this find. I have told you about this in the previous video as well. I will told you here as well. Let us just pass the parameter first. It should be v0 and int b is equal to find parent v1. So now what is this find function? This find is simply the disjoint set union function. It is a very common function and you should study about it as well. So what will be the return type of that function? It will be an integer type. Then you can compare the values now. So in find, you are passing the what? We are passing the vector parent, and you have to pass this vector parent by reference. So you do not create further copies of it and increase the time and space complexity. Passing by reference is so much important. Please pay attention to it, and you will pass the integer a. Now what we have to do in this find union function, if a is equal to parent of a, that means if it is already is equal to its parent, then we simply return the value. But if it is not the case, we will update the parent by calling the find function recursively and passing the vector and passing the parent of the current vector. Okay, then the parent is getting updated, and finally we return the parent. So this all is happening for the union function. What it means, you are comparing 5 and 15 and you are returning 15. It simply means that when you have returned the value, you will check whether if max element of a is equal to max element of b or not. Because when they are equal, there is a separate case of frequency multiplication, yes or no? And when they are not equal, what you will do, you will check which one is bigger. Either max element a is bigger than max element of b. Max element we have to write, yes. And for max element, what I told you, that for if 5 and 15 are there, so the parent of 5 will be 15. That is what is happening. So what we will do, if a is bigger, then we will assign max element of, then we will change the parent of b to a. That is what it means. That means smaller value have a bigger parent. 5 will have a parent as 15. Smaller value have bigger parent. That is what you are updating. And if a is not bigger than b, then parent of a should be updated to b. Okay, this is what is happening. And if this is not the case, if the both elements are equal, that is max element a is equal to max element b, that is a and b are equal and they are having frequency 2 and 3, then what you have to do, you will write parent b is equal to a, or you can also write parent a is equal to b, whichever you like, because in this case both the max elements are equal, and you will multiply it by frequency. How you are getting the frequency? You got it in the count map, yes or no? So you will multiply the frequency count a into count b. You are getting the frequency multiplication to get the number of good paths. You are adding those paths to the answer. Okay, and you also have to add it in the count function to update the frequency. If you do not do this step, you will get an error in certain test case. So I have to write this step. Okay, so it is count b plus is equal to count a. So you are updating the frequency array as well, and we are updating the count. And when all of this is done, you will return the answer. Don't worry, I know it is a hard question. I will explain it again in brief. Let's just check whether it is running or not. What is happening? Parent n I is n equal to I. What is? Oh, we have made a mistake here. It should be parent I is equal to I. Small mistakes, huh? Even after so much of practice. And what is this? Oh, we have not written the data type of these vectors. These really small mistakes makes a big difference, so please practice it. Even I am practicing it as well. Okay, here also so many mistakes, but finally it is running. This is the satisfaction. Let's submit this and check whether it is accepted or not. So yeah, it is accepted. So let me just brief you the question and approach again. So the question was not so simple. It was saying that we are given a tree and we have to return the number of good paths. So the minimum answer would be the number of nodes available, and you have to find other good paths. How can you find the other good paths? You are applying a disjoint set union function, which gives you the maximum function. So first step we do, we found the maximum. That is, we sorted the edges according to their weight. And after we have sorted the edges, we are assigning the parent to it. So we can always get a possible good path available or not. Okay. So that was our approach. We created a parent vector, we created used maps, we sorted the function, we applied the disjoint union function by using the find operation, and ultimately we got our answer. I hope you liked the video. I know it was a tough question. If there was any doubt at any step, please let me know in the comment section. Do like, share and subscribe. And also the time complexity for this will be n+mlog n, and what will the space complexity? Please write it in the comment section. Thank you for watching. Bye bye.